All right, so you should have that bracket open or available for you if you downloaded it. So please go ahead and double click on that bracket and try to open it up. And we're going to go through the same process that we did last time of creating the orthographic views. But in addition to that, we're going to pile up the dimensioning. So all the rules that we learned about dimensioning from the hardware lecture, now we're going to go ahead and apply it. So I'm going to give you about 5 minutes, or actually less than that. And I want you to go ahead and create a drawing. Go ahead and put the top, front, right, ISO, put the hidden lines, put the center lines and center mark, and basically get it ready so we can put dimensions on it. So again, if you guys forgot, we're going to click on Make Drawing from Part, select A ANSI Landscape. Okay, and there are 3 ways that we talked about, so it's really up to you which method you want to use. And again, I made the same mistake, so please don't forget to change it to third angle projection. So we're going to right click on sheet 1, click on properties, and change it to third angle projection to make sure that it is following our layout. So all of you should have something like this. Now, of course, we learned last time how to also create your own sheet format. So if you didn't want to pull the A ANSI Landscape, you could have pulled your own sheet format, and that would have been perfectly fine. Okay, does that make sense? So just like before when we learned about assembly, we had to put all the parts and the assembly in the same folder. We have to do the same thing now. You cannot separate the parts from the drawings. Okay, because if I go ahead and delete this part, all those boxes will turn and they will have a kind of an X mark in the center, and that's how you know that your parts and the drawings are not in the same place. So for example, when you come here and you're trying to open up the drawing, if the part is still on your laptop, it's not going to happen. Okay? So the first thing I want to get across is any changes that you actually do to the part will automatically change in the drawing itself. Okay? So the first thing I want to teach you is how to use something called the hole wizard. So I'm going to minimize this. I'm going to go back to the part. And last time we talked in class during the hardware lecture, what is the meaning of a counter bore and a countersink. So I'm going to show you there's a tool in Solidworks that's called Hole Wizard, and that can actually create that really fast for you. So here's how we can do it. Let's say I'm going to put a counter bore right here. We're going to follow the exact same steps as drawing any sketch. We're going to click on the plane, hold down the control key, and go normal to. Okay? Now remember, this entire part was actually designed in millimeters, so that's why you see 65 millimeters and 68. And we learned from the lecture that if we don't have any decimal places, or if we have only 1 decimal place, it's automatically in metric, in millimeters. If we have 2 decimal places, it's going to be in inches. So some of the homework problems that you see, you should automatically understand what unit system we're using just from the number of decimal places. Okay, so we're going to go under features. And there's an option called Hole Wizard. You see that? So if you go ahead and click on it, it will take it a second to think, just because it will be running a lot of calculations. So when you're using this on your laptops, just make sure that you don't freak out and you start clicking everywhere. So once I open this, you'll notice that I have 2 tabs on the top. One that says type, and the other one that says position. First we have to specify the type, and the second thing we do is we specify the position. So under type, notice what we have: a counter bore, we have a countersink, we have a regular hole. So from here, let's, for now, since we're just using this as an example, let's go ahead and select counter bore. Then under standard, we have an option of ANSI inches, ANSI metric, and all these different options. Now considering that we designed this in metric, let's go ahead and select ANSI metric. Okay? Now under the type, notice that we have different types. Considering that this is just a general exercise, usually if I give you homework with a counter bore, I will specify exactly what type of counter bore you're going to have to choose. But for now, let's just go ahead and stick with the hex bolt. All right, then we come to the sizing. Now, SolidWorks has some library of different sizing. So notice if I click on that drop-down menu, I'll see M5, M6, M10. For those of you who don't know what this means, it's approximately the diameter in millimeters. So if it says M10, it's approximately 10 millimeter diameter. Okay? And you're going to see how that is done in a second. So let's go ahead and click on M10 for now. Alright, and we're going to do a normal fit. Now, sometimes Solidworks does not have every specific bolt that you need. Let's say you need to specify a counter bore that is not in the library of Solidworks, but it's 10.5. So what you can do is you can select 10, and you can come over here and you can click on Show Custom Sizing, and you can see the sizing over here. So from here I can see that the diameter of my counter bore is 21.48, the depth of my counter bore is 6.85, and the diameter of my the neck is 11. Okay, so that's why remember I said M10 is about 10 millimeters. So that's just an idea for you of sizing, but there's always it has a different scope. Does that make sense? So now what you can do is, if you want to customize those, you can definitely change those by typing in whatever you want, and so on. Does that make sense? Alright, so last time we also talked about if a counter bore should be a through all, right? If the neck cuts all the way through, or if a screw only has a specific, a countersink has a specific depth, that's where you specify it. So if you select blind, notice that that gives you the option to actually type in exactly what you need, and for now let's just go ahead and select through all. Is that clear? Any questions on that? Alright, so now we're gonna, once we specify the type and the sizing, we're gonna go ahead and click on the position tab. Now the position tab, you'll notice that your cursor will change it to a pencil with a point on it. What you're really positioning is the center of that counter bore. So if I hover over here, you'll see that it's kind of giving me an idea of how this, or the sizing of that counter bore. So I'm going to go ahead and just place it somewhere, and I'm going to hit escape. Okay, so hit escape so you only place only one of them. And you'll see what happens here is this is a blue dot, so it's underdefined. That means just like any sketch, I have to fully define it. So using the Smart Dimension tool, I can say the distance from here to here is, I'm just going to pick a number for now, I'm just going to say it's 18. And the distance from here to here is 25. Okay, so you'll notice now that the center of that circle turns black. It's fully defined, and on the bottom it tells me fully defined. So just like any sketch, I have to make sure it's fully defined. Does that make sense? Any questions on that? So once you're done, once you're satisfied with this, you can go ahead and click on the check mark, and you see that a counter bore was created for you. Now the way a counter bore is created, you'll see that basically what they do is they draw this profile and they do a revolve cut. Okay, but it's kind of saved already in SolidWorks on how to do this stuff. That's why you can use the whole wizard. Does that make sense?
Is there things like that you can do, that you can program or have set, so like every time you need it again, like shapes that you want the ball to?
Yes, but if I tell you how to do that today, then you won't come for more lectures. Okay, I will show you how to actually program all custom tables when we get to the advanced section. So we'll program our own custom materials. We'll program our own custom sizing. We can actually, there's websites out there that have their own library of stuff, so we can download all that stuff, and you're going to see that we're going to use something called the toolbox, and we're going to use another website called McMaster, where we download all these bolts. So we don't design bolts, we don't design screws, because they're already available for us on the shelf, so we can just buy them. So they're available also in SolidWorks format that you can just download them and use them in your assembly. Okay? Alright, does everyone have this? So now if you go ahead and click on minimize and you go back to your drawing, you'll see that your drawing got automatically updated. Is that clear? Any questions on that? Now you'll notice that considering that this is a counter bore, it is a cylinder, so we have to kind of update our drawing a bit by using some more center lines and center marks. So I'm going to grab the center lines, I'm going to put some center lines for the counter bore over here, and a center line for the counter bore over here, and I'm going to use a center mark for the counter bore over here. Okay, because it's just like any hole, it's going to require a center line and a center mark. Is that clear for everyone? The reason I'm showing you this is one of the key things that we talked about in terms of dimensioning is how do we dimension a counter bore and a counter sink, and you're going to see that SolidWorks is going to do that for us really fast. Okay, are we good? All right, so we're going to start by showing one idea of dimensioning, okay? And then I'm going to delete those. I'm going to show you another possibility. So if we look over here, what view is this? But if we're talking in terms of cylinders or hole cuts, is this the rectangular view or circular view? Circular view, right? So this is the rectangular view. So technically, if this is a cylinder, I need to dimension it in my rectangular view, correct? All right. So remember we talked also how we measure from one edge. So try as much as possible to group everything from one edge. So here's how we can do this. It's very simple. We're going to go to Smart Dimension. So if you want to take a look at it for a second before you start doing it. And here's the deal, guys. So you're going to see something that pops up in a second. So I'm going to do from here to here. And you see these kind of two pieces. So if you remember in the lecture, I told you there's something called Solidworks Moon Tool, right? That's what this is doing. Okay? So you can actually just click here, and it will position it automatically for you. Does that make sense? Now I can also do from here to here, and from here to here, and I get that. Okay? Now, one of the important things that we see here is that those numbers are actually not horizontal. Okay, so it's opposite to what we learned. So I want you to go ahead and finish this, and I'm going to talk about how we can update those numbers. Okay, does everyone have this?
Minus the vertical
Yours
numbers. Yeah.
horizontal numbers?
I have vertical.
You have all of you have horizontal?
Yeah.
Lucky you. All right. I hate this part because SolidWorks asked me if I want to carry over all the stuff that I customized in my older version. I said no, and now when I saw this, I remembered what I did in the older version. Now, when you do it on your home copy, you're actually going to get this. So it's good to know how to fix it, if I can remember how to fix it. Under Options, you go to Document Properties, then you go to Dimensions, and we're going to go to Linear Dimensions. And you'll see here one of the options says Text Position, and you can see it's hovering over the arrows. We're actually going to try to put it between the arrows. Okay, and we're going to change it from ANSI, from ISO to ANSI. Okay, and we're going to do the same thing with, so it's already in it. We're going to do the same thing with the document. And once you hit OK, there we go. Okay? Now, next week, I'll show you how you can actually save all your hotkeys as a folder, as a file, and no matter to what computer you end up going, you can actually just upload that file, and it will take all your hotkeys, all your customization, and will load it on the new computer. Okay? So did everyone get this? Because make sure that you do that. Now, you'll see this is a good thing. Now, if you remember, we talked about grouping. Do you see how the grouping is nice here? Because using that Moon tool, it will actually group it automatically for us. If you think this is too far away, you can always go to Options, and there's an option called Grouping or Spacing, and you can actually decrease that number, and that will decrease automatically too. Does that make sense? Okay, so let's try now and do the other side. So I'm going to do from here to here, and I'm going to do from here to here. So do you see how it pushes it automatically? Although I did the out ones first, and then 65 was kind of here on the bottom, and then I did the inside, it got pushed up, so the spacing is nice and equal. Are we good?
Yep.
Do you see now why, because this is a hole here, I cannot dimension the diameter of the hole from the rectangular view? Because dimensioning the diameter of the hole from the rectangular view will basically make us dimension hidden lines, which is an absolute no-no. All right? So we have this. This is good. Now let's go to the top view. So here's a cool piece of the top view, guys. So we have this counterbore, right? The biggest question is, how to dimension this counterbore? Are we going to have to dimension the outside, the inside, and do some manipulations? There's a very cool option here. It's called hole callout. Do you see it? It's under weld symbol and finish and surface finish. So if we click on that, and then I come over here and I actually try to click on the counterbore, it will tell me all that information. See that? So it will tell me the diameter, it will tell me the counterbore size, and it will tell me the depth. Okay, some of you might ask, can I actually dimension the outside circle instead of the inner circle? Okay, you absolutely can. Okay, it's up to you. You'll get the exact same thing. I mean, and I delete that. But notice, this is actually a good exercise here, because you remember if you're actually doing a sketch and you try to dimension the same thing twice, it will tell you overdefined. I just dimensioned the same thing twice. It's not going to tell you. So that's the whole idea about double dimensioning. You have to be aware of when you double dimensioning, because Solidworks is not going to pop up a message that says, hey, you're double dimensioning. Okay, is that clear? Now I can also do the same thing for this hole. So although this is not a counterbore or a countersink, I can use the same tool. I can go to hole callout, I can click on that circle, and that not only gives me the diameter, it also gives me the depth, which is very good. Okay, are we there? Any questions? Alright, so now we need to dimension the distances, right? So considering this is the circular view, we need to dimension the centers of those circles in a circular view. Now, we're going to go to Smart Dimensions, and if we go from this side to you have to be careful here. Don't click on the center, because that will give you an angle. Try to click on the x-axis, and that will give you the distance in between them, alright? And we're going to try to do the same thing with the bigger one. And by the way, even though you don't, the spacing happens, if you want to change that spacing, just grab them and move them around, and it's very easy to move, okay? Just make sure that you don't jam them inside each other. Is that clear? Okay, now we also need to do it from the other side. So we need to do from here to here, and from here to here. Do you see now how there's an overlap here? My numbers got overlapped. So one possibility is I can grab the front and I can actually move the entire front down, and that will make it look better. Or if it was too much that I can't fit it there, here's a situation where putting dimension between views does not really work. So I could have put it, over here on the top. Does that make sense? Another possibility that I want to show you, so let's say this is 32.50. Now this is 32.50, it's the half of 65. Makes sense? So basically it's telling us that this is centered right here in the middle. Another way of actually representing that is I can go, you guys are not moving enough, the light sensors are going off. Alright, I can go to Sketch, I can grab a line, and I can basically draw a construction line. And that construction line could be drawn from the center, right? So I'm going to draw a construction line that goes from here to here. And then what I can do is I can go to Annotations, Note, and I can basically put a note here. Now what is that note? Notes usually are used to type in whatever you want. So you can use a note to type in your name, you can use a note to type in surface finish, whatever it is. But for you guys, it's going to be a symbol. And the way I can get that symbol is over here. You see where it says Add Symbol? I can click on Add Symbol, and this will open up many possibilities. So there's a default menu, which is modifying symbols, but look how much there's inside of it. See how each one of those menus has like a sub-menu. But for now, all I need is a center line, which is CL. I hit OK, check mark, and there we go. So if I see this, it's automatically assumed that everything is centered with respect to the center line. So it's kind of the same deal as dimensioning it to be 32.5. Make sense? Any questions on that? So do you think we're missing any dimensions, or is this good? Which one are we missing? The curve? Where's the curve? This? Do you guys think we're missing this one? Because this is an arc, right? But it's extruded as in cylinder. That's why I dimensioned it over here, diameter of 65. Okay? What else are we missing?
What about the small piece on the end?
The small piece at the end. What are we missing there?
The width?
The width. So if we go to smart dimension, the only thing that we need from this view is a width of 15. You know, this is probably like going down too much, so I'm going to grab it and pull it back up a bit. And there you go. So do you think this drawing is fully dimensioned? Yes? Yes, it is. Okay? So if you're ready to, remember, you're not ready to turn this in, right? You can't submit this because one, on the bottom it says dimensions are in inches, and remember we're using millimeters for this one. So you have to change that. You have to put your name and date and so on. But any questions on this method of dimensioning? I want to show you another method in a second. Are we good? Okay. I see smiles. I'm not sure if those smiles are I'm going too fast or yes, move on.
Yes.
Okay. Are you guys giving me the silent treatment today? What did I do? Okay, so look at this. We're going to use something, a different way of dimensioning. So remember we talked about datum. Now I don't expect you to select datums for your homework because you don't really know what are those parts used for. So that's why we have to, just pick a line, and usually I pick the base and just measure everything from that base. Now another way of dimensioning is instead of selecting Smart Dimension, if I click on the drop-down menu, there's an option called Vertical Ordinate Dimensions. So the reason you use this is it just creates a cleaner dimensioning scheme. So look at this. If I click on Vertical Ordinate Dimension, I come over here and I select where's my 0. So I click here, so that's my 0 line, and it gives me a 0, so I click here. Now look at this. If I want to dimension this line, I click on it, it gives me 15, it gives me 30, it gives me 55. But no arrows, it's much cleaner, right? So this is another possibility of using ordinate dimension. Does that make sense? I can do the same thing over here. So if I want to remove these guys, I can say I'm going to use Smart Dimension. Again, Vertical Ordinate Dimension. I'm going to go from here, make this 0, dimension this guy, and dimension this guy. Okay? I can also do it horizontally. So I can say Horizontal Ordinate Dimension, and I can measure this to be my 0. Okay, and I can take it to the top or to the bottom. It's up to you. Again, then I can measure this piece, this piece, this piece, and this piece. Okay? Does that make sense? So I'm just showing you another possibility. Is that clear? Any questions on this?
Yeah, if we are going to do it, would we have to change the
No.
text?
Good question. So for horizontal order dimensions, the text has to be this way. Because otherwise, imagine this text is turned and this text is turned, they won't fit on each other. Okay, so it's okay just for, in this case, to have the text vertical. Nathan, you had a question?
No, that was actually.
Okay. All right, so I want to show you one more thing. It was one of the topics that we talked about, two more things that we talked about in the lecture, which is multipliers. Right? If you have two circles that we want to say 2 times, how do we do that? And chamfers. So I'm going to go back to my part here for a second, and I'm going to add a chamfer just for use in this problem. So I'm going to click on this edge, okay, and I'm going to go under the Features tab, and under Fillet, there's an option called chamfer. Okay? So it selected the whole thing, but I think this is too big. 10 millimeters is too big. Let's say we're going to do 2.5. Okay, so we have a small chamfer that goes all the way around. Alright, so we have a chamfer on the top, and again, just for practice purposes, I'm going to put a fillet on the bottom so we know how to dimension a fillet. So I'm going to try to add a fillet somewhere here. So I'm going to click there. I'm going to go into the Features tab and click on Fillet and try to add a fillet of 10 millimeters. And go ahead and click check mark. Okay, so I added a fillet on the bottom and I added a chamfer on the sides. So I'm going to minimize this. I'm going to go back to my drawing and everything should be updated. Now I can see from here that I can see my chamfer, right? This is my chamfer. I can go to Smart Dimension and I can click on Chamfer Dimension. So click on the drop down menu under Smart Dimension and I can click on Chamfer Dimension, and then all I have to do is just select the chamfer itself and then select the x-axis, and that should give me a side and an angle. Okay? So just like we learned in class, do that again? Yeah. So I'm going to go click on the drop down menu under Smart Dimension. The last option is called Chamfer Dimension. So look at what I'm going to click. I'm going to click on the actual incline of the chamfer. Nothing happens, and then you have to click on the x-axis to reference it with respect to that, because that angle needs to be referenced with respect to something. So then I'm going to click on the x component. I hit escape, sorry. Chamfer, line, x, and there we go. And just move it so leader line is pointing up, and click in order to fix it. And you can, move it around when you're done. Is that clear? Now for the radius over here, remember we said leader lines should point up. So if I go to Smart Dimension, I can just hover over that edge and I can, dimension the radius. Now if you notice that when I do Smart Dimension for the radius, instead of getting only the two halves that I can put a dimension, left or right, I can actually have the four sides, and if I put it right there, that's fine. Or some of you might say I'm going to put it right there. It's up to you. Okay, I mean this is still pretty clear, although it's not pointing up. Does that make sense?
Is there anything wrong with it going up and left?
Up and left this way?
Yeah.
No, I just try to avoid. You see those extra lines?
Yeah.
I try to avoid those as much as possible, so I put it here or here so it doesn't really have those extra extension lines. Okay? Are we there? Okay, so one more thing. If we click on Note over here, do you see where it says Note? I can click on Note, and Note basically allows me to either add a note at, if I click on a surface, it will give me the point, the arrow, or I can just put a note somewhere here and I can type whatever I want. The same thing that we did before when we modified the sheet format. Now the cool piece, let's say over here, let's say there's two of these guys. Okay, so there's two of these guys. So what do? We're going to click on this, and I can see all my dimensions over here. So the way this is programmed, the way this appears is shown over here. So it tells me diameter, right? I can see everything between those brackets using Solidworks terms. All I have to do is just go right before it and say 2, and it tells you, do you want to modify it? You say yes. You say 2 and then capital X and then space. So 2x there's no space in between them, because remember, space is only used for chamfers. 2x is for multipliers, and then followed by space. So I have 2x. Now the issue here is what you just typed was a text. So if you go back, for example, and you change your part, and now your part has 3 of them, that text is not going to be updated because it's not being referenced to like an actual. It cannot detect, there's 2 of them or there's 3 of them because you entered it manually. Does that make sense? So that's something for you to kind of keep track of as you go through your problem. Any questions on this? Okay, so this is dimensions. Do you feel that now you have a good understanding on the hardware piece, right? If I look at the drawing, I can detect the mistakes in it, and on the software of how to actually create a good one. Okay, so we good? All right, great. Let me